Here are some more solution questions from the 2015 Chemistry Regents exams. We're starting here with question 4. So you have information up here, and now let's take a look. So it's asking you to draw 2 water molecules in the box showing the orientation of each water molecule toward the copper 2+ ion. In me just taking a look at this right now, maybe I should have put it under bonding instead of solutions. But originally when I was reading it, I was thinking, oh, ions and water. Doesn't really matter. We'll take a look at it now. One of the things that you have to remember, and it's a good review anyway, is that water is a polar molecule. You have polar bonds, but also that water is a polar molecule. That means it has a positive end and a negative end. Oxygen's more electronegative, so that's the negative end, and then the hydrogen atoms are going to be the positive end. Well, opposites attract. So all they're asking you to do is to literally draw 2 water molecules, but I want the oxygen end right closer to the copper 2+ ions than the hydrogen end. So sorry for not drawing them so great, but that would be an acceptable answer. And notice it said to draw 2 of them. So just make sure that you follow whatever the directions are. All right, let's take a look at number 5. In question 5, you're asked now for a numerical setup. So a numerical setup means that you're going to go ahead and plug the values into the formula, and that would be your answer. So in this case, they're looking for you to calculate concentration in parts per million of dissolved copper 2 ions in a sample of water tested. Once again, let's grab the mathematical formula here, put it down, and then plug in. So here it is under concentration, parts per million. I need the mass of solute over the mass of the solution times a million. Okay. It's actually just like percent, except instead of multiplying by 100, I multiply by a million. All right. So for short, I just write ppm, and that's the mass of the solute over the mass of the solution. I'll just abbreviate it SOLN times a million. Now here's where I might run out of room, so okay, here's my million. All right. Now I have to go back into the reading passage. And of course I'm looking for numbers. So the tricky part is that you got to make sure when you read it that you know which is which. Obviously, 6.75 times 10 to the minus 4 grams of dissolved copper ions is our solute, because we want to know the parts per million of copper ions. So I'm just going to put 6.75 times 10 to the minus 4 grams. And that's going to be over the solution. Remember, the solution is going to be the grams of copper ions and the grams of water. We just got to watch the wording. Now it says, according to the report, 550 grams sample. So that sample then is both. So I'm just going to have that in the denominator. So 550 grams. And don't forget, times a million. If you leave that off, you're not going to get credit. So there you have a numerical setup. Now it said numerical setup. You don't have to put units. I like to put units, but you definitely have to show all of your numbers. All right, let's check out the next question or questions. Again, we have a reading passage here, and we're looking at 6, 7, and 8. All right, in question 6, it says state evidence that indicates the proportions of components in rubbing alcohol can vary. When I took the test for myself, when this Regents came out, to be honest with you, I wasn't exactly sure what they were asking. But if you go back in the reading passage, they talk about 70% of rubbing alcohol as far as by volume and 91%. So that turns out that's the answer, that rubbing alcohol is available as 70% and 91%. And of course, remember that percents are parts per hundred, they're proportions. All right, let's move on to question 7. Identify the property of components that makes it possible to use distillation to separate 2-propanol from water. Well, 2-propanol is an alcohol, and it's, of course, a liquid at room temperature. As it says up in the reading passage, it's sold in stores, right? You buy it in a bottle. Water, of course, is a liquid. Distillation, you're going to separate by boiling points. So that's what they were looking for there. That's the property. And then finally in question 8, it says determine the maximum volume of 2-propanol in a 132 milliliter sample. Well, I got to go back up into the reading passage, and it was a 132 milliliter sample that was 91% of this alcohol. So it's percent. I need to go get my percent formula. Let me get rid of this. And here it is. Right? Percent is always the part over the whole thing times 100. Now in this case, you know the percentage. The percentage is 91%. Oh, I'm making a mistake here. Let's write it first. We have percent is equal to the part. In this case, it's going to be the volume over the whole thing times 100. Yeah. Don't just jump into it. Write it down. So I have 91%. Usually I'm solving for that, but in this case they gave it to me. I want to know the maximum volume of the 2-propanol in the sample. The sample's the whole thing. So I want to know the part over 132 milliliters times 100. So again, use a calculator. Your part is your X. So you need to go ahead and divide both sides by 100, for example, and multiply by 132. And you should get an answer of 120 milliliters. You can always check it by putting it in 120 divided by 132 times 100, and it should be 91%. A lot of students got this wrong when this original, this Regents first came out, but you just got to follow the words. Once you find the formula, just go ahead and plug in according to the formula. Keep working hard and check out the next part for more solution questions.